Mars confirmed to have lightning. Dust storms electrify the red planet for decades. Scientists theorized that Mars could experience electrical discharges, like lightning. Now, direct evidence confirms the phenomenon. Electrical activity, including sparks and discharges, occurs within the Martian atmosphere. This discovery makes Mars the third planet known to exhibit lightning, following Earth and the gas giants Saturn and Jupiter. How Mars generates lightning. The process behind this Martian lightning is unique. Unlike Earth, where lightning typically originates in water-rich clouds, the red planet's thin, dry atmosphere relies on triboelectrification, the buildup of static electricity when dust particles collide. Mars is notorious for its massive dust storms and swirling dust devils, creating ideal conditions for this charge separation. The research team used the microphone on NASA's Perseverance rover to capture electromagnetic signatures and acoustic signals over 28 hours of observation, spread across 2 Martian years. The team identified 55 electrical events, with nearly all occurring during peak wind activity. This strengthens the conclusion that wind-driven dust is the primary trigger. Why this matters? Implications for exploration and habitability. The presence of electrical activity has several key implications. Surface chemistry. Lightning could alter the Martian surface chemistry, potentially accelerating oxidation and affecting the preservation of organic molecules. This is crucial for understanding the planet's past habitability. Human exploration risks. The thin atmosphere makes electrical discharges more potent. Space hardware is now known to be at risk of damage from electrostatic buildup, with the Soviet Mars 3 lander being a tragic example. It failed within seconds of landing in a dust storm. Future research. The discovery will spur further study of Martian atmospheric processes, potentially using orbiting spacecraft or ground-based radio telescopes. On Earth, the electrification of dust, sand, and snow particles is well documented, particularly in desert regions, but it rarely results in actual electrical discharges, says study. Co-author Baptiste Chide of the Université de Toulouse in France. On Mars, however, the thin CO2 atmosphere makes this phenomenon far more likely, as the amount of charge required to generate sparks is much lower than on Earth. Laboratory confirmation and future studies to validate their findings. Researchers recreated Martian dust storms in a lab environment. They used a replica of Perseverance's SuperCam camera to observe the same electrical discharges, confirming the robustness of their conclusions. Looking ahead, scientists plan to deploy specialized instruments and refine atmospheric models to better quantify electrical phenomena on Mars. This research will be critical for understanding the planet's environment, ensuring the safety of future missions, and assessing the potential for long-term human settlement. The discovery underscores that Mars is not just a geologically interesting planet. It's an electrically active one, with implications for its past, present, and future.